Welcome to Securing Enterprise-Grade Serverless Applications. My name is Gerardo. I'm a solution architect from the Sydney office in Australia, and I'm excited to be here. So today, we're going to be talking about two of my favorite things, serverless and security. But why do we build serverless applications in the first place? For most builders and for the customers that I talk to, it seems as though they don't want to spend time doing what we call at AWS undifferentiated heavy lifting. Instead, they want to free up engineering time so they can focus on what really matters, which is the quality and the functionality on their code, and also pushing those features as fast as possible to your users. But speed is only one side of the equation. Just like when you go out skiing, you want to get top speed, but you don't want to compromise your own safety. At least some of us are very sensible and we don't want to hurt ourselves. In software development, it's very similar. You may want to make sure that you have a quick development cycle, but you also want to make sure that keeping security a top priority so that you can protect your customers and your customers' data. So today's session is somewhat advanced. I would say it's around 250 level, maybe round it up to 300. It's not going to be a dive deep on any particular subject of serverless or security. Instead, we're going to be covering a whole bunch of principles and best practices that you need to consider if you want to make your serverless applications secure. It'll be more like a low-altitude flight, where we're going to be looking over a couple of subjects, in particular on architectural principles and some development practices. There are some things we're not going to cover, and I'm going to tell you what you need to consider towards the end of the presentation. I'm hoping that you're going to get a few insights on this and hopefully inspire you to become a faster, more secure developer. So let's get started. We're going to start with a very standard serverless architecture. Here we have, let's say, a web application that you have on Amazon S3. You are delivering that to your users using Amazon CloudFront, which is our programmable CDN. You're exposing your application APIs or your microservices APIs using Amazon API Gateway. These are the front doors to your application. And then on the back end, you have each of these microservices represented as one or many AWS Lambda functions. Just like it happens with some microservices, you could have, some of those are going to have independent data stores, and I'm just showing you here two examples, a non-relational data store using Amazon DynamoDB and a relational database using Amazon Aurora serverless, because we're talking about serverless applications today. So where do we start if we want to secure this application? Well, in my time in the industry, I've seen that when customers have a bad day in terms of security, it generally boils down to two foundational areas. Either issues with their identity posture or their foundational identity services, or maybe a lack of multiple redundant controls or applying security at multiple layers. So we're going to start with the first one, identity, because identity is one of the most critical, or perhaps the most critical component to get right in your serverless application. So specifically, if you want to authenticate users and you're going to have some users accessing your serverless application, you're going to need a database of users or maybe some sort of directory. So how do you authenticate these users? Some people, and including myself, when I'm coming up with new things and just experimenting, we store the credentials in a database. So we create user profiles and we store them in a database. Who here has seen credentials stored on a database? Or have you stored them or seen them stored on a database? OK, now keep your hands up if the credentials have been stored in plain text. OK, a couple of hands up. All right, I've done that myself, and we know that it's not good. And the reason it's not good is multifold. So let's recap on the perils of storing your own credentials. Because even if you store the credentials in an encrypted at-rest database like Amazon DynamoDB or like Aurora Serverless, both of which are encrypted by default at rest, you're still storing the credentials in plain text, which means anyone with rightful access to the database can access all of the user's credentials. And that could be bad. It could be a rogue employee could access all the credentials from your users, and that's not good to maintain that trust with your users. And also, or an attacker impersonating that rogue employee or somehow getting access to the database has access to everything. So this is not good. Something that was used to be very popular a few days ago is hashing the passwords. But we know that today this is not good enough, because attackers can very easily use techniques like rainbow tables and dictionary attacks to unencrypt them. So that's not good. Something that's much better is salt hashing the passwords. But when you're salt hashing the passwords, then there's a specific mechanism that you do it to get it right. For example, you need to incorporate API-specific salts and some random user-specific salt. So it can be hard, and it's not ideal, because before salt hashing them, you're still transferring the credentials over the wire before they get to your backend. So what can you do? Now, you should aim to implement something like Secure Remote Password Protocol, or Secure Remote Password Protocol, SRP, which is a workflow developed at Stanford that prevents multiple of the common attacks on identity stores. Now, and just like a workflow, this is hard to implement. So this is not something that's just going to encrypt your credentials in your database and that's it. So this is an entire flow. So it's not easy to implement, and we haven't even started talking about other essential identity functionality, like how do you sign users up? How do you verify their emails? How do you verify their mobile phones? What happens if they forget their password? So all of these workflows need to be part of your application, probably, and it's not something that you should be doing in this day and age. Instead, you should be using a serverless, standards-based identity store service, such as the ones offered by Okta, Ping Identity, Auth0, and of course, Amazon Cognito. Now, Amazon Cognito is going to do the secure password handling for us using SRP. It has other things like, because it's serverless, it can scale to hundreds of millions of users, so you're not going to have to worry about scale until a certain point when you get into billions, and at that point you need to give us a call and we'll figure it out with you. It's built on standards. It supports SAML 2.0, OAuth 2.0, and OpenID Connect. And what that means is not only we get confidence that the service is doing what we're supposed to be doing, but also that it's interoperable. So we can easily integrate Cognito with multiple other systems. And what it means for you, for using a managed service for identity store, is that you can stop worrying and working out all the logic and all the glue that you need to work out for managing all these type of flows and all this essential identity functionality. You can focus more time on what really matters: your code, the quality of the code, and releasing the features fast to your users. Now, Amazon Cognito is comprised by 2 services under the hood. I'm not going to go into detail on this, but you should know that Amazon Cognito User Pools is that directory, the managed directory for your users, and that it handles the authentication side of things. So verifying that the user is who they say they are, whereas Amazon Cognito Identity Pools is what handles all the permissions on AWS for that particular user. Now, after we've added Amazon Cognito to our serverless architecture, we're going to keep going with this. And there's one consideration that we need to make, because with Amazon Cognito User Pools, you're creating a new directory. But what happens if you already have that directory of users? How do you manage multiple identity stores into your application? Well, the answer to this question, if you want to keep it in best practice, is you don't. And please don't. Because when you have multiple identities as part of your application, then you have multiple attack vectors. And not only that, it increases the complexity of the things that you need to configure. Instead, you should be centralizing all the identity management using a single centralized standards-based identity service, such as the ones we spoke about, and also centralized privilege management. This is a secure best practice for serverless applications, and it's very similar to the server full world. Just like in serverless, we can use some of these abstracted services that are serverless-based as well. Now, if your users are using, or they are stored in another, let's say, identity provider that is OpenID compatible, you can delegate them into Cognito so that you can have them locally in your app. If you have an enterprise directory, such as Microsoft ID, you can federate those, and still, it will seem for your serverless applications as one identity for that particular user. It's also a better customer experience, because you don't want those users to remember multiple passwords and have multiple types of identities if they already have one. One added benefit of actually going this path is it's going to force you whether you like it or not, after you federate it and delegate it, it's going to force you to use roles-based access control as opposed to having long-term IAM credentials. These long-term IAM credentials are a really bad practice. They're a frequent attack vector. And for security, you need to start thinking about how do I start using more temporary access keys. And this is something that is enforced when you use delegation and federation. Now, federation is talked a lot, so I'm not going to spend time on it. But I do want to show you how delegation works for Amazon Cognito. Now, with delegation, if you're using Cognito as the identity provider, the user is going to log in and going to share the credentials. They're going to authenticate against user pools. And then user pools is going to request developer identity. And these are tokens. We're going to talk about these tokens in a second, JWT tokens. For now, you should know that they are a stateless way, self-contained, of sharing identity information. We'll get to that in a second. These tokens return to the client, and that what normally happens is you try to assume a role against AWS STS, or Secure Token Service. You share those tokens, and then STS validates that the tokens are valid, and if they are, it returns these temporary credentials for you. Now, this is a secure flow, because you're getting temporary credentials. And if you're using the AWS SDK, these credentials are going to be refreshed for you. You don't need to worry about it. Very secure, best practice. But in serverless, a lot of the services that you use in serverless are JWT aware. And what that means is that you can heavily simplify this. So you can get rid of that entire second part and simply start sending just those JWT tokens to the backend services. For example, Amazon API Gateway, if you expose your APIs with it, is JWT aware. You can use things like any OpenID Connect provider with it for authorization. And it also has a very nice feature of integrating natively with Cognito. The same happens with AWS AppSync. So if you're running GraphQL APIs instead of RESTful APIs, it's also a service that is JWT aware. Now, the main job that you have as a developer is looking after those tokens properly in the client. So you need to make sure that you store them either as a secure cookie or in the browser's local storage, encrypted, and with a mechanism that allows you to maintain that encryption secured. So let's talk about these tokens a little bit before we move on, because the tokens are important. So JSON Web Tokens, or JWT tokens, or even sometimes called JWT tokens, are cryptographically verified JSON claims that cannot be altered. Now, Cognito implements 3 types of token. We're going to talk about those in a second. This is an example of one of those, an identity token. And these tokens are comprised by 3 64-base encoded parts concatenated by a dot. The first part is a header. It contains a pointer to the key used to sign the token, and also a reference to the signing algorithm. The payload of the token contains all the identity claims, and this is the meat. This is what you really want to know as a developer, because here you can have things like username, email address, date of birth, first name, whatever it is that you're collecting from your user. If you're using Cognito user pools as your identity store, you can configure multiple additional claims by using custom attributes. Once you configure a Cognito custom attribute, then that attribute is going to flow through with the tokens for every user that authenticates against Cognito. So this is very useful for your downstream development to get context from the user. And finally, there's the signature. The signature is only there to validate that the token is valid and that it comes from the source that it claims it comes from, in this case, from Amazon Cognito. This looks complicated, but you don't actually, it's not that complicated once you start interacting with the tokens using either the AWS SDKs to validate that tokens are valid, or there's some open libraries that you can use as well to interact with the token, right? You don't need to do the encoding and decoding yourself. Now, Amazon Cognito, as an OpenID Connect provider, implements 3 types of token. The identity token that we saw before contains the identity claims and is used for authorization, for authentication reasons. The access token can be used for authorization. And the way this works, and this is an optional thing you can do, is part of the auth standard allows you to define parts of your application that need to be more secure. And unfortunately, these are called resource servers. We're talking about serverless. And here we have a standard that calls this thing resource servers. Anyway, you define the resource servers, and then if the access token contains a custom claim to access those resource servers, then it's going to be allowed. So this is for authorization. It's optional. We'll see in a second how it works. And finally, the refresh token. This is only there to make sure that you can get new identity and new access tokens. The reason these are important for you is because these tokens heavily simplify what you need to do as developers in the backend to get user contexts. So every time that an API request comes from the user, now it's going to have all the identity or the identity claims from the user right there, so you don't have to interact with other services to get that information. So very useful. Before we finish with identity, which is the first principle we're discussing today, we need to make sure that we implement least privilege. This works in the server full world as well. And for serverless services, IAM, AWS IAM, is still at the core of serverless security. So here we have an example policy that is the one that you see on your left-hand side that is using some wildcards. So it's allowing any action against DynamoDB against any resource. This is not least privilege. Instead, you should be doing what we have on the right-hand side, which is you allow the DynamoDB specific action that you need only to the resource that you need. So the principle of least privilege is allowing only the minimum privilege necessary for the intended action that you want to make or the functionality in your application. So you need to remember two things. Scope down your policies and avoid the use of wildcards. In scoping out your policies, there's something else that you can do. And you can use something called IAM conditions. Now, IAM conditions are a special optional attribute of IAM policies that allow you to further have dynamic conditions for allowing access. So for example, here I have one that is very simple. You want to allow two actions against a specific S3 bucket in S3, but you only allow those actions if the requester's IP address is part of the 172.0 block. So this is the type of policy that you would have if you are only allowing to access an admin person from the internal corporate network or something like that. There are a couple of conditions that you can implement for serverless applications. There's one very nice that I'm going to show you later today. But you should definitely take a look at this. So in summary, the first principle we talked about is you should have a strong identity foundation. Consider using and centralizing identity management or using a serverless, standards-based identity service, and also centralizing privilege management with AWS IAM. This is, in turn, is going to force you to, when you're centralizing, to use delegation or federation, depending on where your users are, user information is stored, if they are stored somewhere else. And finally, it's also going to force you to avoid or eliminate your reliance on long-term IAM credentials, which are a common attack vector. So principle number one. For principle number two, we're going to talk about applying security at multiple layers. These are the two things that I mentioned before that generally happens when companies have a bad day in terms of security. And this principle is important because security events have multiple sources. Obviously, we'll have in our mind that there's an attacker who is just trying to get into our systems, but that's not always the case. It could be a bot out in the internet poking all these services, trying to see what's vulnerable, and if it's vulnerable, it gets in. It could be a rogue employee. It could be someone from your own company that actually doesn't have the best intentions for your users. It could be your code. Maybe you pushed some bad code that opened up a vulnerability. So the more layers that you have across multiple components of your application, even if they are redundant layers, are going to prevent one small mistake from actually becoming a big security event. An analogy that I like about this is like peeling an onion. So if you're going to peel an onion, there are multiple layers that you need to go through, and by the time you get to the core, you're probably going to be crying. So it's important that we add some layers to our serverless application. So where do we start adding security layers to our serverless application? I'm going to suggest we start with our API, because APIs are normally the front door to our applications. And I'm going to talk about three things and three layers that you should apply on Amazon API Gateway. The first one being access control. Now, Access control for Amazon API Gateway has multiple things you can do, multiple authorizers you can configure. You can generate your own API keys and use that. You can use AWS IAM. If you have an OpenID Connect provider, you can use that. Or there are others, but one that I like is obviously the native integration with Amazon Cognito. So let me show you how that works. After a user has authenticated, all the upcoming requests are going to include these tokens. Once they hit your Amazon API Gateway, if API Gateway hasn't seen these tokens before, it's going to push that to Amazon Cognito. And Amazon Cognito can do either of two things. It can check whether the tokens are valid and they came from me, from Cognito. And if they are, here's your access policy, Amazon API Gateway. You go and authorize this user or not. Optionally, it can help you with what we talked about before of those resource servers. So you can configure some resource servers to define parts of your application. And then if that custom claim is included as part of the access token, it can allow access. So very two simple checks. One is very binary, either valid or invalid. The other one gives you a little bit more finer access control. But they're still somewhat simple. So if the permissions are denied, of course, Amazon API Gateway is going to reject that API call. But if the permissions are allowed, that call is going to be pushed through with the tokens in it, plus a context that Amazon API Gateway is going to construct for you. So as a developer, you can do either of two things. You can interact with the token in your Lambda functions downstream, or you can just simply inspect that payload of token, because all the identity claims are going to be there thanks to API Gateway that is doing that little job for us. OK, but these are two very simple checks. And we know that we want finer access control and least privilege in our applications. So what if you want to do something more custom? Something like, let's say you have a subscription plan. And you want to provide access to your users based on their plan, if they're in the bronze plan or the silver plan or the gold plan. But at the same time, you only want to give them access if they've actually paid for the subscription. So you also want to check on things like subscription status. This is more complex than that. And today, you can't do this kind of validations in Amazon Cognito as an authorizer. What you should be using instead as an authorizer is something called a Lambda authorizer. The principle is the same. So the tokens go to Lambda authorizer. But then you write your own business logic on how you want to authorize this request. You can check the subscription plan. You can check the subscription status, whatever it is that you want to do here. The world is open. It's whatever you write in your code. When you do that, or when you use a Lambda authorizer, you need to come up with two things, and optionally a third one. Now, we give you a template so that you don't have to do these things from scratch. But you need to basically validate that the token is valid, that this token is valid, and that it comes from the source it says it comes from. You can do that if it's Cognito. You can do that with the AWS SDK. And secondly, you have to come up with a policy. You need to return a policy for every request and every JWT token that you receive. Optionally, you can come up with the context that we talked about before. And you can include things here not only because it's more flexible now, not only from the identity token, but you can interact with external services, get more information, and put that in your context that you pass downstream to your services to make development for your downstream developers, developing for your downstream developers even easier. Now, if the policy you return is invalid or the permissions are denied, of course, this call is not going to go ahead. But if the policy is valid, it's going to be cached over a TTL. So every time that there's a new token coming to API Gateway, you don't have to trigger this Lambda function over and over and over again. You can configure this TTL. And if the permissions are allowed, the API call is going to go ahead with the tokens and the optional context that you might have created in your Lambda function. So we've seen two types of authorizers for Amazon API Gateway. This is just one layer. This is just access control. But something else that you can do on your API is it helps you comply with this principle, security principle of never trusting user input. Some of us that have been building applications for a while, we know that we shouldn't be trusting user input. And there are multiple ways to do that. One way that Amazon API Gateway can help you is with some basic request validations. There are only two things that you can do today with this. One is API Gateway can check whether the parameters, the query strings, and the headers exist in the request and they are non-blank. Otherwise, it can block that for you. And what's more important, it's going to check that the payload actually adheres to what you configured as the JSON schema request model in your method, in the specific method that you are accessing. This is a lot more powerful, and it means that at least the components of the request are similar to what your API is inspecting. These are not all the validations you need to make, but at least they are offloading you as a developer in a couple of ways. You still need to do some deep input validation as part of your backend, but hey, we are offloading some of these things from you. So we talked about access control, and we talked about request validations. A third thing you can do, and a third layer you can apply to your APIs, is to help you with CORS. Now, CORS is a standard that's been out there for at least a couple of decades. It stands for Cross-Origins Resource Sharing, and it's a security measure that you need to implement in some browsers. Sorry, no, you implement them in some APIs to let browsers access them. The consequences of having CORS misconfigured could range anywhere from getting some data stolen or actually having the site completely compromised. And the way it works is before a browser makes that GET request or that PUT request that you want to make, the browser is going to send an options request to the API, expecting some permissions back. In the past, or before the serverless world, we had to code in our applications how to respond to these core requests. It's not fun. And one thing that API Gateway can do for you is it can mock these responses. So you can configure what headers, what methods, and what origins are allowed for this particular API, and thus offloads you as a developer from having to do that in your backend. And it also prevents things like if you push bad code to your backend where you were doing this, you may be opening up things. So remember, adding security layers, even if they are redundant, in multiple parts of your application. So this is the API. We talked about access control, request validations, and CORS. Let's move to another layer of our application, Amazon DynamoDB. With DynamoDB, IAM is still at the core of the security, and here we have access control. So in this example, we have two users that can assume a role with that policy, with that user policy. It's allowing them to get an item from DynamoDB, but only from that particular table called inventory table. So this is very straightforward, right? But what if these two users are from different customers? And what if you want to make sure that users can only access the parts of the database that they own? You don't want to have the risk of one user accessing someone else's data. This is another layer that you can apply. Generally, in relational databases, there are some features for this. Generally, what developers do is they write some custom code in order to do these kind of things. But if you're using Amazon Cognito, if you're using DynamoDB, and of course, AWS IAM, there's a pretty cool native integration that allows you to, with the use of this condition, DynamoDB leading keys, allows you to inspect the partition key of that request, and if you pre-appended the user's own identity ID as part of that partition key, then it's going to basically make users only access the parts of the database that are prepended with their own Cognito identity ID. So this is a bit of a mouthful. But what we're doing here is basically we're making the user's own identity define the boundary of what they can access in DynamoDB, and we didn't have to write a single line of code. This is super cool, and if you're using Cognito and DynamoDB, you should go for that. Now, let's move on to another layer of our application. Let's talk about Amazon S3. S3 by default is private. So not only S3 buckets, but all the components inside the bucket, objects, lifecycle policies, websites, all of those things are secure by default. But just like everything in AWS, we want to give developers the chance to make them public. And sometimes they make mistakes. So they make public more things than they want. So there's a couple of layers that we can apply to S3 to secure that further. There's the user policies, the normal user policies that we've seen for DynamoDB and for API gateway. So these are policies that are assigned to users, group, or roles that define access to the particular S3 bucket. But we also have this other concept of resource policies. In the case of Amazon S3, it's called bucket policies. So this is another policy that you attach to the resource itself, and it defines who can access me, what actions can be made against me. So it's a two-pronged strategy here, and as you can guess, by applying multiple security layers in multiple parts of the application, you should do both. Now, I didn't know if there's a third one, and I didn't know if it was going to be launched at Andy's keynote this morning. It did, so I can tell you about it now, and it's S3 access points. So there's a third strategy that you can use here by defining access points. And access points, you can have hundreds of different access points per bucket, and then have individual policies for that access point. So instead of having to define a single policy for everything that sits inside the bucket, now you can have multiple access points, so you have more control of what type of data to share with whom. So it's just another one of those strategies, not part of my slides, but you should look it up, S3 access points released this morning by Andy Jassy. All right, so let's go to the horsepower of serverless. Let's go to AWS Lambda. The good thing about this is because you're using AWS Lambda, it means that you don't have to worry about security. AWS is doing everything for you, right? No, not right. It is true, there's a lot less things you need to worry about. So AWS is managing the underlying infrastructure, the foundational services, the operating system, and the Lambda application platform is handling your code, encrypting your code at rest. But you're still responsible for the security in your code. You're still responsible for making sure and protecting your users' data and the way you're accessing data using these Lambda functions. We are responsible for making sure that AWS IAM works in the intended way it was supposed to work, but you are responsible for configuring the policies for those IAM policies and conditions. So yes, even though you're running serverless and there's a lot less you need to worry about, you still have some responsibility. So let's talk about how does AWS IAM work for AWS Lambda. There are two sides to this. First, there's a resource policy, similar to the one we saw for bucket policies. In a resource policy, you define what can invoke me. As a Lambda function, who can trigger me? It could be any S3 bucket. If you want to make it least privileged, you define the specific S3 bucket that can trigger you. Remember that Lambda can be triggered by almost a couple dozen of different services. So you want to apply also least privilege here, making sure that your Lambda functions are triggered only by the specific services that you want them to be triggered. And the second part to this is what can Lambda do? What can this Lambda function do? And you define this on the execution role that you assign to Lambda and the access policy that this execution role has. So this is going to define what actions can the Lambda function do. And just to make it slightly a little bit more complex, there's a third policy called trust policy, which is part of the IAM role and defines who can assume this IAM role. So your Lambda function needs to be there so that it can assume that role. And after it assumes that role, the access policy of that role defines what actions can my Lambda function do. All right, so let's switch gears for a little bit. We've done access control and a couple other layers in our APIs. Let's talk about application vulnerability. Just because you're running serverless applications, bad news, it doesn't mean that you are not exposed to common vulnerabilities of the internet. So you're still vulnerable to things like DDoS attacks or cross-site scripting or SQL injection attacks. So let's address these ones, and starting with DDoS attacks. So who here has experienced a DDoS attack? Yeah, not a lot of fun, right? Who here has performed a DDoS attack? Don't raise your hands. I don't know. I don't know if that's illegal or something. So distributed denial of service attacks are a type of attack that intends to disrupt normal traffic from getting to your application by overwhelming it with a lot of traffic coming from multiple places. And that coming from multiple places is the trick, right? Because if it's coming from one place, you just block the IP and there you go. But if it comes from billions of IoT devices, then it becomes something really hard to manage. Now, the best practice, one of the best practices to see in this case is In the security world, there's this principle of reducing your attack surface. So if you have 11 ways or 11 fronts on which to be attacked, if you can reduce that to 3, that's better. It's better because it's simpler to manage those 3 attack surfaces instead of 11. Right here, we have 3 attack surfaces for DDoS attacks. Route 53 configurations, CloudFront distributions, and your APIs using Amazon API Gateway. And right off the bat, we can reduce our attack surface by 1, because we don't need to expose the APIs to the public. We can force our users to access our APIs via CloudFront. So 1 out of 3 is gone. We still have 2. Now, the good news is that all AWS customers in all AWS regions for all AWS services benefit for free from the protections of AWS Shield standard. And this is the catch. It's just a standard version. Now, Shield standard protects you against level 3 and level 4 types of DDoS attacks, so things like SIM floods, UDP floods, and other types of reflection attacks. And this is good because it gives you some peace of mind. But if you're building enterprise-grade serverless applications that are mission-critical and you cannot afford any downtime, you really need to configure or need to consider a more sophisticated DDoS mitigation service, such as upgrading to AWS Shield Advanced. Because AWS Shield Advanced gives you protection at the application layer, protecting against things like HTTP floods, and it also gives you access to a response team so that in case you're actually under attack, they can apply some proactive measures like traffic engineering and things like that. So what you need to remember here, just because you're doing serverless and AWS is doing the scaling for you, it doesn't mean you're not vulnerable to DDoS. You still need to consider a sophisticated DDoS mitigation service, especially for those enterprise-grade serverless apps. Now, let's move to another vulnerability, cross-site scripting. Cross-site scripting is one of the top 10 risks for web applications as per OWASP. And for those that are not familiar with this, it's very simple. It's about the attacker injecting some JavaScript code into a website that then everyone else downloads and execute on their browsers. So as an attacker, you do one simple thing. You inject the piece of code, and then it executes in everyone else's that is using that website. Now, here we have an example. Here we have a HTML tag. For those that are developers out there, this is something very simple. And what's doing this is, on an image tag, it has some functionality that runs some JavaScript code when the user puts the mouse on it, on that area of the UI. And what this is doing is popping up the cookie. Now, this is a very naive attack, because as an attacker, you don't actually want to pop something on the user screen. You want to steal stuff, right? So you do something like this. So you inject a script that actually gets that cookie, for example, and send that over to a server that the attacker controls. And even though this is an insecure server, you can see it's using HTTP, not HTTPS, the user is not going to notice, because all of that happens under the covers. So let me show you what the Firebug trace would look for this kind of attack. So you can see that on your left-hand side, you can see that the application is actually hitting the server that the attacker owns, and you can see on the right-hand side that it contains that cookie. Very easy way to steal information, and this is a very common attack. Now, there are multiple variations of cross-site scripting attacks, but the principle is the same. You're injecting some JavaScript code that someone else runs. And although modern web frameworks like React, Angular, the majority of them include protections against cross-site scripting, but developers, we still have some of the responsibility of implementing this correctly, and just like developers are, we sometimes forget. And when we do, this thing can go unnoticed, and then our application can be actually open for cross-site scripting attacks. So AWS can help with this by applying one layer at the front called AWS WAF, or Web Application Firewall. The way the Web Application Firewall works is it gives you control over what type of traffic you want to allow or block, defining some custom web application rules, and also defining some type of very common attacks. And it is as simple as creating an access control list, or ACL, defining some rules within that ACL, and then attaching that ACL to your resource, CloudFront distribution, or an API gateway resource, or an Elastic Load Balancer, whatever you want to attach it to. Now, there are four examples that I'm showing here of things you can do within AWS WAF. You can filter by region. If your application isn't intending to deal with requests from certain areas of the world, why allowing the calls in the first place? That can only be bad. So you can filter that before it hits your application using AWS WAF. Cross-site scripting, we talked about this. You can, AWS WAF can detect this for you and block it. If your application is not configured to deal with payloads of over 1 kilobyte, why allowing that through? That can only lead to bad things. So you can block that using AWS WAF, and of course, there's another one called for SQL injection attacks, which we're going to talk about in a second. So you can see WAF is a layer you can apply to your serverless application that offloads some of this responsibility for you, and just with adhering with best practices of applying security at multiple layers, this is something that you should really consider for your serverless applications. The last type of attack we talked about there is SQL injection. And this is another of the top 10 risks by OWASP. These two, cross-site scripting and SQL injections, have been there for many years, and they still are common vulnerabilities. And this type of attack works similarly in that when you're requesting input from the attacker can, as part of the input, embed some extra SQL code there. So this is an example. Let's say that your application is expecting to execute that first line. So it's expecting the user to give it an email address, abc@domain.com or whatever. Instead, the attacker sends what's in red there. So the email address, and then tick, semicolon, drop table context, semicolon, dash, dash. So what do you think is going to happen if this goes unchecked? Yes. So it's the command is going to execute. It's going to execute the command that the developer was expecting, but then it's going to drop the table content. And this is a very nasty one to embed there, because it's basically deleting an entire table from your database. But an attack like this could do anything. It could pull the entire database and steal the information. So this is another example. Let's say that your application is expecting a first name, and instead the attacker sends this cryptic message of tick or 1 in ticks equals tick 1. This is not as obvious, but it's equally as dangerous. So what happens is that all of that is going to evaluate to true, and as a result, this command is going to pull every single employee from that table. So very dangerous and very simple attacks that can lead to massive leaks of data. So let's look at how this attack type of attack would work on Lambda, because we're talking about serverless. Now, Lambda is different, and the reason that why SQL injection attacks are different for Lambda is because Lambda can be triggered by a couple dozen of AWS services. It could be a file is pulling from S3. It could be a synchronous API call against API gateway. It could be a queue on SQSQ. And if the input of that file sitting on S3 or that message sitting on SQSQ includes the attack that we talked about, this could be very dangerous. So if you execute within your Lambda function using this very standard snippet written in Java, this is going to go undetected. And the result is going to be that what we expected it to be. It's going to be pulling all of the employee records from the database. So how do you protect against this kind of attacks in SQL injection? Because AWS WAF does it for the traditional web applications, but when you're talking about Lambda, you're executing Lambda in different ways. So AWS WAF is not necessarily going to protect you in all cases. So how do you protect against this as a developer? Well, the solution to that is making sure that you use prepared or precompiled SQL statements. The idea of this is that you are parameterizing all the queries so that your Lambda functions expect a single input. And this is an example. Using Java, again, these pieces of code are expecting a single input. So even if the attacker sends multiple inputs and add this extra SQL to the queries, the attack is not going to work. So this is the best practice. You need to make sure that you use prepare and precompiled SQL statements when dealing with relational databases in the backend. So let's recap the second principle we talked about today. You need to apply security at multiple layers. You need to think about defense in depth. You need to think about that onion and the attacker crying if they really want to get into your application. All these security layers need to be redundant and at multiple parts of your application. So you need to consider multiple things. These are all the layers that we added in our talk so far. Now, the third bit we introduced, or the type of attack that we talked last, was SQL injection and using precompiled SQL statements. Now, this is something you do in your code. So we're suddenly not talking anymore about architectural principles. We're talking about secure coding practices. So I want to give you a couple of secure coding practices, the third and last principle that we're going to be talking about today. You might have noticed that I've avoided talking about how to securely access relational databases. And the reason I did that and I left that towards the end is because, yes, there are some architectural things that you need to do. If you have your relational database on a VPC, you need to build a connection. You need to protect that connection and configure VPC constructs like security groups or NACLs. But the majority or one of the most important things that you need to do when accessing a database connection is how you access those credentials from your code. So this is a quick example. So if you want to access a relational database using Node.js, you will need to write something like that. And you will need to give it a username and a password. And because you've been in this session for 50 minutes now, you know that users need to have their own temporary credentials. And actually sharing those credentials or having a different set of credentials is not great for security. So how can your code access credentials? There are a couple of ways you can do it. Of course, you can hard code them, and we all do this. Every time we're coming up with a new application and experimenting with an idea, we first hard code the credentials, and then we solve it before we push it to production, unless we forget. And if we forget, it's bad, because every developer or every administrator that gets access to the system can read your code. Or sometimes you do what I did recently, which is push it to GitHub for everyone to see. Why not? So secrets in plain text in your code, bad idea, don't do it. Instead, you can look at things like using environment variables or config files. AWS Lambda allows you to pass dynamically some variables at execution time. These are called environment variables. So they become environment variables in your runtime. So you can access them very easily in your function. However, the reason why this is with exclamation mark is because there are secure ways of doing it and insecure ways of doing it. So if you use encrypted environment variables and you have a mechanism for encrypting that and then your code accessing the key and then decrypting it, it's secure. But there's some work that you have to do. So wouldn't it be nice if there was a way that it was not only secure but also simple to implement? Yes, there is. And it would be using an external secrets manager, such as AWS Secrets Manager. And the reason why this is a lot more secure and a lot simpler is because Secrets Manager is going to store the credentials securely for you. You don't need to worry about encryption, and the only thing you need to do is configure the access policy using IAM, our centralized privilege management service, to define who can access these secrets. But the storage of the secrets, don't need to worry about it. As a developer, we all like to use methods on an SDK. So you interact with Secrets Manager using the methods, and that way you retrieve those secrets, and then your code can easily embed those secrets when you're accessing your database. And finally, but not least, AWS Secrets Manager includes a very powerful feature that is going to rotate the credentials for you without impacting application uptime. So if you're running things like Amazon Redshift, RDS, or DynamoDB, Secrets Manager can rotate the credentials for you, and because you're using the SDK, you don't need to worry about it. They refresh on your application without you having to work on it. Now, so these are 4 ways that you can access databases. Of course, I recommend the 4th, but wouldn't it be nice if we could get rid of these database credentials altogether? Because they are generally the same credential every user uses, to access the same database? Couldn't we have something like a separate type of credentials per user? This is something you can implement with some work in some relational databases, but what I'm going to suggest we do is we use IAM Authentication for Amazon RDS. Because what this is doing is getting rid of those credentials altogether. What you need to do is access or request the access token from the service RDS, and then it's going to give you an access token that lasts for 15 minutes and that you use to access your database. So everyone gets a different token. It refreshes every 15 minutes. You can see how this is a lot more secure than using the same username and password, even if you use a Secrets Manager to handle this, right? OK, this is pretty cool. But we still have a database connection. And I don't like this database connection. It means we need to open up ports. We need to worry about networking security. Wouldn't it be nice if we could get rid of the database connection entirely? The answer is yes. So last year ago at reInvent, we launched the data API for Amazon Aurora Serverless that allows you to do just that. So it basically gives you a couple of commands on your SDK. You can execute SQL statements against your database. Now, this only works for Amazon Aurora Serverless. And all you need to worry about is about using the SDKs correctly and then defining the permissions for the user to be able to access RDS data and Secrets Manager. Secrets Manager, because under the hood, we're not actually changing the way MySQL and SQL Server and Oracle databases work. They still work with these credentials, but we're managing all of that for you and giving you just an API. The same API you use for Lambda, for API Gateway, for DynamoDB, now you can use it as well for your relational databases. Very powerful. In that way, your application has become end-to-end serverless, end-to-end API-driven. Cool. So there's 6 ways that we talked about of accessing relational databases. 1 is insecure. 2 can be secure but require some work. But 3 of those are simple and secure. You should obviously go with one of the last 3. OK. Before we go, one last coding practice that I want to, or secure coding practice that I want to share with you. Some of us are familiar with the concept of monolith versus microservices. Here we have an example of a Lambda function that is a single Lambda function for the entire application. Any API call goes to that Lambda function. And that Lambda function has to contain the code functionality for anything that comes to it. As a result, it also needs permissions to access all the things that are behind it. So this is not least privilege. By moving to microservices, you split that Lambda function into separate small functions. And what I'm arguing today is that not only microservices are making applications easier to scale and faster to develop, I'm also saying today that they also help you enforce least privilege, because now your permissions are going to be much smaller, because all the components in the microservices can access a lot less resources. Something else that is important for Lambda functions is, we're not going to get into the details of how the architecture of Lambda is under the hood, but let's say that the micro VMs on which Lambda is built are not shared across different customers. They're just for you. But the execution environment that sits on top of that micro VM can be reused for you, for another executions of your own Lambda function. As a result, you shouldn't be sharing any information on that execution, on that runtime. If you need to pass information to other components of your application, you should be using external services like SQS or SNS topics, and this is the concept of event-driven architectures. So when you build microservices and event-driven architectures, you are a faster developer. It helps you be more secure and also be a happier developer altogether. All right, so something else that you can take from home, other coding best practices. These are not necessarily just for serverless, but it'll help you think about the things you need to consider. And I'm going to give you one example, error handling. So in Lambda functions, there are multiple ways you can do error handling. And the way we have error handling is because we want to give the developer some feedback to debug and troubleshoot our applications. Now, with error handling, in Lambda, you can do 2 things. You can push those logs to AWS CloudWatch logs, good thing, or you can return these errors back to the user, so when you're a developer working on your application, you can get that as a user. That's not good, because if you push that to production, you may be inadvertently leaking some information to someone else when there's an error that could be used against you to exploit your application. So in Lambda, you need to do login using AWS CloudWatch logs, which is the standard way of doing it. So something to read for home. Things we didn't talk about today. This session is not intended to cover everything about security, because it's a big topic. I want to make sure that you know 3 things we did not talk about today. Modern applications have security embedded in every step of the application lifecycle. So maybe go watch another session at reInvent on security considerations for software release. We didn't talk about protecting data in transit and at rest. If you run serverless applications in AWS, in this day and age, there's no excuse for not using end-to-end encryption. So you need to actually take this very seriously. And finally, there's a whole topic about security operations. How do you get visibility into security events? How do you respond to these security events? Why not responding automatically to these security events instead of having to have an expert come up if you have the information at hand? And how to recover from a security event if you had a breach. So things we didn't cover. We did cover a lot, though. If you want to learn more about serverless, you can go to aws.training. There's hundreds of digital free courses there. Some of those are related to serverless. But what we learned today is just because you are running serverless application, it doesn't mean you're not vulnerable. The threat model is the same. Maybe you have less things to do, because AWS is taking care of a lot of those things for you, but you still have some responsibility, and the approaches and the tools that you use are different from the tools and approaches you had in the serverless world. So, to close, these are the 3 principles we talked about today. You need to implement a strong identity foundation, use a centralized serverless directory service that is based on standards like OAuth and OpenID Connect. You need to use centralized privilege management. In AWS, that is called AWS IAM. You need to eliminate the reliance on long-term credentials and make sure that you still configure and least privilege. You need to apply security at all layers. Make sure that you have a very deep and very layered onion for attackers to go through. Multiple things we talked about: access control, request validation. You shouldn't be trusting user input. We talked about DDoS, cross-site scripting, AWS WAF, and AWS Shield. But nothing stops, or nothing is better than having actually good, secure coding practices. So a lot of responsibility is still on us. You should be building microservices and event-driven architectures, because not only they help you scale applications better, release faster, but also it makes them more secure. You shouldn't be sharing anything on the Lambda execution environment. Instead, use external services to communicate or send information across the multiple components of your system. Never trust user input. You should be validating. You should be encoding, using precompiled SQL statements. And finally, no secrets whatsoever in plain text in code. You should be using an external secrets manager, or getting rid of that secret altogether using things like IAM Auth and the data API for AWS, for Amazon Aurora Serverless. So I'm going to hang around if you want to have a discussion after this. But remember, just like when you go skiing, you want to get top speed, but you don't want to compromise your own safety. It's no different in software development. You can take advantage of the speed that serverless gives you while still making security a top priority. I hope that you're as excited as I am in becoming a faster, more secure developer. Thank you.